Hey everybody, welcome back. We're starting chapter 11. Not 21. This is chapter 11 and it is on two population hypothesis tests. In 11.1, we are doing a two sample proportion test. Next week, we will do 11.2 and 11.3 together. 11.2 is on a paired means test. So we're working with means, but there's a connection between the samples. And 11.3 will be a two sample means test. Not paired. And that'll be next class. As a quick little recap of some of the stuff we've learned so far. We have learned about confidence intervals. I can't spell recap, apparently. Recap. We've done confidence intervals, which I tend to call CI. Because confidence intervals is a lot of letters to write and you get tired of writing it. And this is a range of values. That is based on sample data. That is likely to include an unknown parameter. We've been working with P. We've been working with mu. We look at standard deviation. We look at variance. Bunch of things we look at. And this is an unknown parameter. The parameter, don't forget, is from the population. The same word applied to a sample. It's called a statistic. All right, and then we have a hypothesis test. This is a process for testing. A claim based on sample data made about an unknown population parameter. This had H naught, which was our null, and had a statement of equality. HA was our alternate. And had an inequality, either not equal to, less than, or greater. That's not how you spell Ulster. There we go. Putting these two kind of together, first off, notice. They're both based on sample data. And they're both about an unknown parameter from the population. When you put them together, what we're really finding out is the value of equality from H naught within the confidence interval. That is what our p-value test shows. If p-value is less than alpha, no. H naught is not within it. Which leads us to reject it. And support HA. If p-value is greater than alpha, it is within the interval. So can't reject H naught. Which means we won't support HA. We can't support HA if H naught is true, possibly true. They can't both be right. All right. That's our recap. Try to connect everything we've been learning since the midterm. Put it all together. If you need that up longer, just shout out, I'll put that. All right, so in this one, we're doing 11.1 is on the two sample proportion test. All the requirements from the one sample proportion test apply. But now to both groups. Or both samples. So samples need to be independent and random. And what does that mean here? One sample isn't affected by the other. That's what I mean by independent. Random should be like random. Something that would break this. Having guys versus or having guys versus girls. And using a married couple. I'm gonna throw in there heterosexual couple. Can't have the husband in one group and wife in the other, there's connection. Oftentimes you have stuff in common and so they're not independent. I guess that last thing isn't really necessary, cause it's not really random if you have like. Two husbands and throw them in the same group, so like we don't even need that description in there. Just any married couple. Don't use them. So what were the criteria that we had for our two populations or samples? We used to have n times p times 1 minus p had to be greater than or equal to 10. Now we're gonna split this up and talk about two populations. N1 P1 and 1 minus P1. And then N2 P2, 1 minus P2. We also needed N to be greater than or equal to 5% of the big N or the population. This is also going to apply to each group, so we'll use subscripts. And before I show you how to get to it in StatCrunch, I want you to see the formula that we're not doing because StatCrunch does it for us. This is worth seeing, so you like really appreciate what's going on here. Look at that motherfucker.
That's great.
Isn't that great? You have P1, P2, an overall P, which comes from this, and then a couple of fucking square roots. Whole lot of shit going down to get Z, or we let the calculator get it. Not even worth writing down. I want you to be some crackhead that tries to do this shit. Alright, so how do we do it? We're gonna go stats. Proportion stats. Two samples. It will give you the option for with data. With summary. And with power sample size. So that's our stack crunch steps, and then we do need the one step that changes for our hypothesis testing. Step one changes to the following. H naught is. Does P one equal P two? And HA is P one not equal to, less than, or greater than P two? Stack crunch is not gonna look like that though. The way stack crunch shows this. When you put in the hypothesis stuff. It shows H naught as P one minus P two. Equals 0. And then HA is. P one minus P two either doesn't equal, it's less than or greater than 0. And they even leave this box empty. Well, it's not empty. You can replace 0. The reason why you would do that is you're not just wanting to show like. Girls are more kick-ass than guys. You wanna show like they're 10% more kick-ass than guys. Right? So we could set where we say like P one minus P two is greater than 0.1 or 10%. Changing this isn't common. This doesn't change often. Monday is a holiday. If you have classes on Monday, do not show up. Your teacher will not be here. That is not helping you get out double classes for us next week though. You took a Tuesday, Thursday class, you get all of them except Thanksgiving. That's good, more data to go all around, more happy. You guys ready for more? So, I'm gonna give you some pro tips. Cause with 2 samples, it kind of makes it a little bit more challenging. So these are FA's pro tips. First off. Read the problem a few times. Make sure you understand what the hell is what it's asking. Two. Label the 2 samples. As group 1 and group 2. As well as. Nah, that's about it. So they're gonna either ask for data for individual groups. For both samples separate. Separated into two columns. Or. They will want T1. The X1 value and N1 value. X, as if you recall, is the number. That meet the criteria or whatever you're asking, said yes. And N is the sample size. And then they'll want the same thing for P2. N1 does not have to equal N2. But it can. When students do hypothesis testing and they decide to go for two groups. Oftentimes they just want balance, so they ask the same number of people, but you don't need it. Alright, for the problems we're gonna do. We are gonna hit the lecture notes that I was showing you last time. This will be on page 123. We're looking at example 2. And example 3. I don't know what page, it's either on the same page or the next one. Another pro tip. I don't know about you, but. For me. Tip 4. Thinking about one group's proportion being greater than another group's proportion. Is easier than picturing. Less than. It's just easier. If you're different, if you're more than happy working with less than, go for it. But for me, picturing one group as greater than the other. And consistently doing that. Use that if you're the same way as me and like that. Pick P1. And P2. Basically group 1 and group 2. So that this is met. Earlier, when I gave the example and I verbally said girls will be better at it than guys. And for me. That would be saying girls are better than guys. And then I assign girls to group 1 and guys to group 2. So that when I do this, I have P1 is greater than P2. But saying it in words, writing in words tends to make it easier. That's my tip. On the final exam, there are 10 questions. There are 2 confidence intervals. There are 8 hypothesis tests. We are going to learn 8 hypothesis tests. That is not a coincidence. You'll have 1 of each. On the ones that have 2 samples, you need to, part of the question is you need to identify the group. Make sure you write it down. So it helps doing it now, get used to it. If you don't identify the groups, having greater than or equal less than doesn't mean anything. Alright, you guys ready for some questions? Have fun watching me mangle the shit out of this word. Rural. Oh fuck, I said it right. That's probably the only time I'm gonna say it right now. So our first example, this is example 2 on the lecture notes. An economist believes. That the percentage. Of urban households. With internet access. Is greater. Than the percentage. Of rural household, fuck, I did it twice. Rural households. With. And I fucked up spelling households, that's great. Let's say rural homes. Make it shorter. Rural, there we go, I fucked it up that time. Rural homes with internet access. You know what, rather than saying rural, I'm gonna start saying country, cause I don't fuck up the word country, and it kind of means anything. So he obtains. A random sample. Of 800 urban homes. And finds that 338 have internet. His sample of country homes. Was 750. Homes. Where 292 had access. Test the economist's claim. Alpha equals 0.05.
They need test 800 of both.
Cause he's like that. I'm happy it was just an even number, to be honest. Easier to remember, okay. So we read through it a couple times, the percentage of urban homes. Is greater than the percentage of country homes. Urban needs to be greater than country. That's what I'm getting from this. Urban is greater than country. So I'm gonna call my urban home group 1. My country home group 2. And this means my X1 goes with the number of urban homes that had internet would be 338. And N1 is 800. X2, my country homes, was 292. N2 is 750. I'm just writing those down so that I have them readily available for when I try to do some stat crunch and I'm not digging for information. You'll find that it's handy to do that. And we go through our hypothesis test. Step 1 is identifying H naught and HA. H naught, since I've labeled them, I can do P1 minus P2 equals 0, which is the same thing as P1 is greater than, or P1 equals P2. Those are the same thing. Stack crunch is gonna use this one on the left. And I set it up so that I would have the greater than symbol here. When you're doing the final exam, you need to give H on HA, either setup will work. Step 2. Identify alpha. Alpha was given to us at 0.05. Step 3. This is our stat crunch step. Test stat and p-value. Ready? Stat crunch open. Alright, we're gonna go stats. P stats. To sample with summary. They give us sample one. Sample one, we said the number of successes, that's X1. This was 338. And there's number of observations with your sample size. The other group, we had 292 and 750. We wanted to go with P1 minus P2 is greater than 0. So we have a Z-stat. This is 1.3, I'll go to 3 decimal places, 329. P-value is 0.092. While I'm doing this, before I switch back, I'm going to show you the confidence interval version of this. We had alpha was 5% and the greater than means we can leave it as 95%. And we have this. The confidence interval is this. What we're doing is we're going, does this value right here reside in between these two? And I've got a negative number on the left and a positive number on the right. 0 is in the middle. So 0 is in the middle. We can't reject it. So do not reject. H naught. That's what we should get when we're doing our p-value test. H naught, the value for H naught is inside it, so we're not rejecting it. Hit clear. And we'll shift back over to Zoom. Or the document camera. So our CI, our confidence interval said do not reject. Because H naught was inside. Let's see if our hypothesis test format does the same thing. Step 4 is decision time. Is p-value greater than or equal to alpha? Or less than? P-value was 0.092. Alpha was 0.05. P-value is greater than alpha. So it's not too low. This is our case of the knots. Do not reject H naught. Do not support HA. And step 5 is where we will have our conclusion. And we'll say that this is where our last knot goes. There is not enough evidence. To support the claim. That And I'm gonna come up and look up here, this was my HA. Urban was greater than country. That the percentage of urban homes. With internet access. Is greater than that. Rural or country homes. And then we'll add in the level of significance we tested it at. At alpha equals 0.05 level of significance. There's something I didn't do, which I'm gonna do now. Cause some of the homework problems might ask you to do it. Check the criteria. I did not confirm the criteria held true. So after everyone's writing this down, I'm going to just show you the process of doing that criteria. Oh, blurry and shit. Yeah, no, don't help. Oh, well. Maybe it's me. The blurry, the buffer looks kind of dim. Alright, so let's check our. Wait, a couple people are still writing. Oh, man. Which you guys on this? Alright. So checking the criteria. We had. X1 was 338. N1 was 800. So P1 is. 338 over 800. Which is. 0.4225. X2 was 292. N2 was 750. If we divide those, we get P2. MF. Some repeating decimal. So we need to check, is N1 times P1 times 1 minus P1 greater than or equal to 10? Is 800 times 0.4225 times 1 minus 0.4225. What does that equal? I'm getting 195 and some change. That is greater than or equal to 10. So that criteria is met. I know for a fact N1 is less than or equal to 5% of N1. 800 urban homes is not that many for a fucking country. It's definitely less than 5%. Then I'll do N2 times P2. Times 1 minus P2. Is that greater than or equal to 10? 750 times 0.389 times 1 minus 0.389. What does that equal? I'm getting 178 and some change, which is also definitely greater than or equal to 10. And we're also gonna have N2 is gonna definitely be less than 5% of N2. We only sampled 750 country homes and there's a shitload of country homes. Just look at those election results. Yeah, one more?
You repeat the N2 is less than 0.05.
Yeah, this one is 750 less than or equal to 0.5. The total number of country homes. I have no idea what it is, what this number is, but I'm sure this is in the millions. And 750 is definitely less than 5% of a million.
It's big N is the entire home's population.
Yeah. Well, in this case, the country. Even if we went with the state. It's still, fuck, if we went with Tulare County, I'm sure it's still less than that. But less confident about county, for sure about state. Does that make sense? Would you guys like another example, or do you want to call it quits and stop project? It's up to you guys. I got more. Any more?
I mean, I got it.
Does anyone else want an example? What, operator? No? Alright, if no one wants another example, I'm not gonna make you sit here and watch. I'm gonna, if you're not talking for my own health, you guys can work on your projects, or you're free to leave, you can get the fuck out. Don't forget, no class on Friday or Monday. I will see you guys Tuesday. Have a good weekend.